Now we come to the second part of this year's Nobel Prize, to Mourou and Donna Strickland. And what you see here is the development of laser pulse intensity as a function of time from the very beginning, when the first laser was constructed in 1960 by Maiman, and up to 1985. And what you see, there is first a rather sharp increase in pulse intensity, but then it levels off. And this became a problem because the technology of that time was not scalable. It was not possible to go to higher intensity because of amplifier damage. And the way to come over this hurdle was the invention of the chirp pulse amplification by Mourou and Strickland. And this was really the core of Donna Strickland's PhD thesis. So the idea and what they demonstrated is the following. You take a short pulse, you stretch it in time, maybe a factor of 1,000, and then the amplitude of the pulse will decrease, also a factor of 1,000. Then you take the pulse and send it through the amplifier. The pulse is increased in amplitude, and finally, in the final step, you compress the pulse so that it has the same duration as your input pulse, but now with a much higher intensity. And here you can see the development of pulse intensity after the invention of the CPA technique. Basically, every 4 or 5 years, the pulse intensity doubled. And this gave a possibility for a rather wide range of applications, both in basic science and in more practical applications. And here you see high-intensity ultra-short pulses. They are between 10 to 100 femtoseconds. 1 femtosecond is a million of a billionth of a second. And in the upper panel, you see very high-intensity pulses coming roughly 1 per second, like this. And these pulses can be used for laser particle acceleration. You want to accelerate electrons or protons, and this is now a development that we can already see could be of importance for cancer therapy in the future.